I'm Wei Heng, and I'm sharing about my object detection project regarding workplace safety. Workplace safety is important because it protects employees, increases productivity, and reduces costs. And this creates three key use cases for object detection, which are monitoring usage, checking for safety practices, and preventive maintenance. Firstly, we can monitor usage patterns. How you may ask? Let's say we have multiple CCTVs in multiple locations that make predictions of their own at regular intervals. When the bounding box of the person and ladder overlap and the person is higher than the ladder, we can consider that as ladder activity. We'll then receive the data from each CCTV and find out which CCTV has the highest amount of ladder activity. What can we do with such information? Let's move on. Instead of having a supervisor at every location, we can utilize the previous example to flag locations that have high ladder activity. This will not only increase the productivity but also reduce supervisor costs as well. And also, we can install fixed ladders in high usage areas, which are generally more safer than portable ladders that these workers usually bring. This concludes the business case. Now let's move on to the annotated image dataset. The dataset is retrieved from RoboFlow Universe, and you can find the dataset source here. Let's now proceed with learning how the annotation process works. So here's how we're gonna do. Since we're doing cigarettes, let's just name it cigarette. Annotation group will be bud. And the reason why it's bud is because to maintain compatibility with the data, we're gonna have to name it with a similar label, which is bud. Object detection, create private project. Okay, and I've uploaded my dataset. I go to annotate. I click on here. I can start annotating the images. Start manually uploading. Let's start manually annotating. Okay, let's go. Zoom in. Annotate. And we should call it bud. Yes. Here got 3 images. Okay. Okay. And now that we're done, we can exit. Add 3 images to dataset. We add all to training because we already have we will have our own testing dataset, and we can press new version, resize it so that it meets the requirements of the project. No augmentation steps. Create. Let it create for a while. Very nice. I will go and download the dataset as Pascal. Download zip to computer. Continue. Okay. And now we can go to, okay, we unzip it. We go and check. Look at one of the XMLs. Let's take a look. Okay, name is bud. Bounding box is here. We start by initializing and making the directory paths as well as annotations. And annotations are lists which represent the desired CSV format by Google. We also have an annotation limit to retrieve the desired amount of 300 annotations. Looking at the main function, which is process_files, we're checking our file issues. This will check that the XML and JPEG files exist, contains annotations for both persons and labels. Make sure that the JPEG file has a resolution of 640 by 640 and the bounding box is valid. Valid bounding boxes means that the coordinates follow logic here that makes it possible to draw a rectangle. However, if the bounding boxes have a value of 641, which is quite common, we'll correct it to 640. If the file pairs do not meet the criteria, then we'll call the move to unwanted function, which moves the file pairs to the categorized unwanted directory. If the file pairs meet the criteria, then we'll call process XML, which extracts the annotations, normalizes the coordinates, add to self.annotation, and increment the self.annotation count. Once the count reaches the specified limit, the loop will break and no more files will be processed. But what are the 2 extra functions below? Create CSV basically takes self.annotations, convert it into a data frame, and export it as CSV. Print summary counts the number of files in each directory and prints the summary message like this. Now let's move on to the verification of the CSV file. Scrolling past the file processing and looking at the CSV validator, we understand that the check it does are to ensure that, number 1, the number of columns add up to 10, the image path starts with gs:// checks the label, makes sure that the coordinates are at the correct locations, check that x min and y min is less than x max and y max, and also to make sure that the columns which are supposed to be empty are empty for each row. It will also check across the dataset that the annotation count is 300, check the class balance, and prints out a report that we can see here. We're also checking that the uploaded CSV matches one-to-one with our training directory by using the set function in Python. Finally, we upload the file, retrieve an image, and get a bucket size, which is 5.32 megabytes. Let's now move on to the training, evaluation, and deployment of the object detection model. So in terms of training the model, all the instructions were followed, so why not let's take a look at the model evaluation. The ladder's precision is very good, but not for the person's precision. Probably because the ladders have this sort of iconic A-frame image, whereas persons can look very different, with sometimes only the legs being shown in the image. Looking at the confidence and intersection over union thresholds, let's define what will happen if we adjust them. So, higher confidence means that precision will increase but recall will decrease, which is useful when false positive, like warning all the supervisors about ladder misuse, could be quite disruptive and costly. Lower confidence has the opposite effect, which is useful for monitoring or cases where you want false negatives, like if you want to be certain that all the ladder activities are captured. Higher IOU means that the model's prediction must fit the strict positioning information set by the high IOU, which would reduce recall by rejecting the correct detections with less accurate bounding box coordinates. Lower IOU means that the bounding box coordinates are allowed to be more loose, which will increase recall by accepting partially accurate detections. Looking at our options, I recommend setting a high confidence threshold for ladder, maybe 0.7, and a medium threshold for person, maybe 0.5. The IOU can be set at 0.5 because it's the industry standard. So to expand on this rationale, specifically the use case of detecting persons on ladders, this dual threshold approach makes sense because the safety cost of not identifying a person on the ladder is higher than identifying a ladder without a person. So to select testing images, we create a testing directory. We get the set of images that we use in training, then the set of all the images available, and find the complement of these two sets, select and move 10 of the images from the complement into the test directory. Then we create an endpoint. We call the test images function, which deploys the model to the endpoint, gets the images from the test directory, predict with the base64 encoded image, save the result to a JSON, and then undeploy the model immediately. Then we draw the predictions with the draw predictions function, which takes in the prediction.json, filter the 40 predictions per image into the top P or top K, draw the boxes with the label and the confidence, and save it into the predictions output directory. From there, we are able to see 3 examples of these predicted images, and across all these examples, the images generally had a high person detection confidence of 91% in clear full body images, moderate confidence of 77% in partial views, and unfortunately, the failure to detect a partially visible foot in the last image. The ladder detection has some interesting patterns with confidence score around from 56% to 77%, and notably, the model is more consistent with clearly visible ladder isolation and a flat ground, but lower confidence to ladders in active use, probably suggesting that occlusion and interaction from the person to the ladder might affect the ladder confidence. So let's go to a reflection. If we want to expand the use case of a model, we can probably generate confidence metadata in the annotation process of the training data, which could help with the confidence distribution of the model. We could also have additional labels or classification models that detect safe and unsafe practices, safety practices. Yes. Finally, if we could consider adding a logic to flag scenarios where ladder detection confidence drops during human interaction, which can indicate ladder usage or potentially unconventional and, as a result, unsafe usage patterns. So my learnings are basically that, especially in object detection, general accuracy and precision isn't everything. Seeing how the relationship between ladder and person confidence score differ on whether the person is climbing the ladder on the very top of the ladder, obstructing the ladder, can influence the confidence score in a way that is hopefully rather consistent, which can lead to stronger use cases than simply detecting objects. Like maybe you can find out the different usage or positioning of the ladder. From a deployment standpoint, when I heard that the requirement was to take down the deployment as fast as I can, the first solution I had was to build the undeployment process as part of the function that tested the image. I know that because of this decision, the cloud computing resource was minimized as much as it could be. From a practical standpoint, separating the testing pipeline into deployment predictions and the drawing of boxes with the test image and draw prediction functions really made it much more easier to debug and even allow for advanced functionality like adjusting the top P and K values. From the Pascal VOC cleaning and CSV validation, I honestly found it quite fun, and the VOC processor was probably one of the most meticulous classes that I've built for data wrangling and processing. I made sure all the requirements were met, have good logging, make sure all the unwanted cases were stored neatly for later analysis. Plus, I also made sure that the requirements of the VOC processor was met by creating a Python script and using PyTest to test against the VOC processor to make sure all the checking functionality was working properly. Yeah, so this was a pretty fun project. Thanks for watching.